Good afternoon. Today we're looking at solving exponential and logarithmic equations. Now we've already solved some we have solved some logarithmic equations, but what I was going to say is we've already solved some exponential equations. So I want to remind you of what we were doing last week for solving exponential equations. For solving exponential equations, we said that an exponential equation is just any equation with a variable in the exponent, and we had two methods of solving. And I said the first way of solving, the first method, was the same base method. For example, I'll make this an easy one. Let's say 2 to the x is equal to 8. Y'all remember using your properties of exponents to get a common base on both sides? What do you think we should use as a common base? 2. 2 is a prime number. We're not going to change 2. That means we better change the base on the right side, 8, to a power of 2. And we can do that by saying 8 is equal to 2 cubed. We can then drop the bases and set the exponents equal to give us x equals 3. And I said that the drawback, that's not really a drawback, to the same base method is you must be able to get the same base on both sides. Suppose we had had something like this example. 2 to the x is equal, instead of an 8, suppose we'd had a 7 there. 7 is a prime number. 2 is a prime number. Are we going to be able to get a common base? No, you cannot get a common base in this situation, so the same base method fails. In that event, we have a second method that requires the use of logarithms. So our second method, the unlike base method. We have the like base and we have the unlike base method. The unlike base method requires the use of logarithms. I'll just say requires logarithms. I think I'll write out a general sequence of steps. I'll say, okay, here's the, but what do I want to call this? I'll just say the steps. Here are the steps. You'll be using your calculator to get a decimal approximation for these answers, so you're going to need to use a logarithm key that appears on your calculator. My calculator only has log and ln. I prefer ln. So I'm going to say the first step.
And I think number 4 will convince them ln is the better.
Take the natural log of both sides. And at this point you have exponential expressions and logarithmic expressions in the same problem. So for a moment it looks even worse than what you started with, but then you can use the power rule to bring down the exponents. Bring down the exponents and multiply. Third step, we're trying to solve an equation, so we want an answer in the form x equals, so we're going to need to isolate x. And that's simple enough, but if you have two x terms, then what you're going to want to do, I'm going to say,
parenthetical expression.
If you have two exponents, two x values, not exponents. If you have two x values,
how about
two
x terms?
X terms, yeah. Yeah. If you have two x terms, I'm going to mark all that out and make it two x terms. Collect them on the same side of the equation and factor out x. Get them all isolated on the same side, and then every term on that side has an x, factor out the x. Step number 4, you'll divide. Whatever x is being multiplied by, that's what you're going to divide by to get x by itself. And then MyLab will want you to enter in decimal approximation. So I guess for step 5 I can say, use your calculator
to get a decimal approximation.
Maybe we should start off just by solving this equation here. It looks painless enough. 2 to the x equals 7.
Let's see what 1 is. Not the...
Oh, yeah. Let's see. Oh, actually, okay. We'll just do number 1 instead. Looks just as good, if not a little better. Okay. Number 1. They say 3 to the x is equal to 4. Look at how I'm writing this stuff down.
Oh, wait, I can't see.
Mm-hmm.
There. You spread it out.
I've spread it out because once we decide, hey, 3 is a prime number, 4 is what, 2 squared? There's no way you're going to write 4 as a power of 3. You're not going to write 3 as a power of 4. So we introduce ln. We take the natural log of both sides, here and here.
So that's step 1.
There's step 1. I took the natural log of both sides. Next step, bring down the exponents. So you pick up, the only exponent we have is x. So we take the exponent, bring it down, times the natural log of 3. So we have x times the natural log of 3 is equal to the natural log of 4. In this case, notice that that there's only one x term. If we had more than one x term, we need to get them all isolated on the same side of the equation. But as it is, x, ln 3 is a number. It's a messy decimal number. It's 1 point something or another, but it's x times 1 point something. What operation do you use?
ln 3 is 1.098612.
So it's x times about 1.1. What do you do to undo that multiplication? divide.
That's step 4.
There's step
it's
4. I think step 4 I just wrote out divide. Yep, there I did. We didn't have to worry about that parenthetical statement. We isolated x. It was already isolated. We divided. And now we're going to use our calculators to get the decimal approximation. Realize we have x equals ln 4 divided by ln 3. How do they want us to round this answer?
Let's see, what does it say?
4 decimal places, okay.
Here, be careful because they don't all say 4 decimal places.
Sometimes they'll say round to the thousandth, tenths, hundredths, thousandths. That's only 3 decimal places. So look at the instructions each time.
If you do 4, they don't tell you, oh, you've rounded wrong. They just say wrong. Okay, so on my calculator, when I hit LN, it opens parentheses. I've got to be sure to close them.
Divided by LN. It opened a parenthesis. When we type that 3, we need to close it. And rounding to 4 decimal places, that's a 1.261. Is that an 8? Mm-hmm. Yeah, not a 3. Okay, this thing's sort of pale there. Okay. Well, is that going to stay an 8 or is it going to go up to a 9?
That must be the angle you're looking at.
Mm-hmm. Yep. So it's a 1.2619. Those are wavy equals just to indicate that I'm writing a rounded value.
Okay, let me move this calculator out of the way. Now, if you'd gotten some sort of error warning when you punched it into your calculator, that's when you would choose the solution is not a real number. But more than likely, if they get an error warning,
they've messed up.
Messed up. Okay.
You've messed up.
1.2.
That should not be happening.
19 on these problems. Right? 1.2619. Mm-hmm. Okay.
Okay, number 2, I imagine it's going to be a little messier. Okay, for a moment, you may look at that and think, oh, we can get a common base. But can we? That's a 3 to the 6x minus 2 is equal to, and you'll notice I'm skipping some space before I write the 6 to the x. Let them see my paper. Okay. Common mistake. 3 is the smaller base, so we'll use 3. What do people do? How do they rewrite 6 incorrectly? Maybe 3 squared. Is 3 squared equal to 6? Mm-mm.
No, if it had been 9, we could do it easy.
We could do it, yes, but 6 cannot be written as a power of 3, so in that event, we take the natural log of both sides, and that lets us bring down the exponent. Realize we have 2 terms up here as that exponent. That's 6x minus 2. We're going to bring it down, and it's going to have to be multiplied by the natural log of 3. We picked up the 6x minus 2. We brought it down times the natural log of 3.
Which is just that decimal number, 1.0.
Mm-hmm. And realize this is just that decimal number. What was it? I'll just say approximately 1.1. 1.1 times that stuff. What are we going to have to do when you have a binomial that you want to multiply by a single number? What are we going to do to get rid of those parentheses?
Starts with D.
Distribute. We may as well go ahead and bring down the x over on the right-hand side. We have x times the natural log of 6. And then we're going to distribute. This is a number times 6x minus 2. So you take that number times 6x. and then the number times a minus 2. This is not a case where you can get creative. 6x times the natural log of 3 is just 6x times the natural log of 3.
Don't actually multiply that 6 and 3 and get an 18. No,
You
no,
don't
no.
have a property of exponents. I guess you could take the 6 and move it up there and get a 3 to the 6th power.
Oh.
You could do that. But you'd be getting such a large base that I think you're just asking for problems. Also, remember, you're going to be punching the stuff into your calculator, and what you have is bases here. You have an ln3, not a base, as an argument. You have an ln3, you have an ln6. At no time through my work should I have anything other than ln3 or ln6. I can't wind up with an ln18. I can't wind up with an ln2. All I can have are ln3s and ln6s. So 6x times ln3 is 6x ln3 minus 2 times ln3 is 2 ln3 equals, and I still have that x ln6.
Show me steps.
Okay, we're still working. We took the natural log of both sides. We brought down the exponents and multiply. That's what we just did here. We brought down the exponents and were able to multiply. Now we need to isolate x. To isolate x, if you have two x terms, collect them on the same side and factor out the x. Our goal is going to be to have x times something, and our last step will always be just dividing by whatever x is being multiplied by. I think I'm going to collect all of the x terms on the left side. I already have a 6x ln3 here. I'm going to subtract.
Move the big old here.
I'm going to subtract x ln 6 to get it on the same side as the other x term. What am I going to do to that minus 2 ln 3? Okay, I'll add it to give me a positive 2 ln 3. Now we have multiple x terms. We're going to factor out an x. If you have two x terms, collect them on the same side and factor out x. That's what I'm doing right now, factoring out x. 6 times x times ln 3. Take out the x. We have a 6 ln 3 left minus, what are we going to have here? You have to factor out that x. Ln 6 x times that quantity. What are we going to do? Divide. So we're going to divide both sides by the stuff that's that x is being multiplied by. 6 ln 3 minus ln 6. 6 ln 3 minus ln 6. So on the left side, all we have remaining is x equals, look at the stuff we're going to have to punch into our calculators. 2 ln 3 is on top, all divided by 6 ln 3 minus ln 6.
Not over here. Have them simplify 2 plus 8 divided by 4 plus 6.
Okay, that's a good idea.
Right.
Okay.
2 plus 8.
Before we start punching this stuff in, let's simplify. I want y'all to help me simplify. Oh, I think I used black here. The following fraction. What did you say? 2 plus 8 all over
4 plus 6.
4 plus 6.
What do y'all know the answer should be? On top, what number do we have? 10. And on the bottom? So what do we know the answer should be? It's not a hard question.
10 divided by 10 is?
Starts with a 1.
Oh,
1, okay.
1, okay. Well, this was a good idea, Tony. I don't care what anyone else is
execution is really bad. I wanted to show,
a good idea.
We know, it's 10 over 10. The answer is 1. But if you punch this into a calculator,
as I
it's
said,
not going to give us a 1. What's it going to do? It's going to follow. What's going to give us a 10?
it's going to go. It'll follow the order of operations. 8 divided by 4 is 2. Then add from left to right. 2 plus 2 plus 6. That's giving us a final answer of 10.
What do I need to do to make this calculator give me the correct answer?
You have to override that built-in order of operations. Tell me, when you're simplifying this, what do you do first?
Yes.
Okay, there it is. So you have to treat that like it's in parentheses. Add the top. You don't want it to follow the ordinary order of operations. You want it to simplify the top, and then what do you want it to do?
Do you want to divide, or what should I do next? Divide or add? You add the bottom.
You're enclosing the top in parentheses, telling the calculator, simplify that first. Then the bottom, you enclose it in parentheses, saying, okay, do that next. And once you have that 10 over 10, what's the last operation your calculator should perform? That division. If you have a fraction in this form, that's anything other than just number over number, then you need to enclose both the numerator and the denominator in parentheses as you're punching it in. Now, if you have a calculator that has that's like the equation editor, where there's a special fraction bar and you're not having to hit a divided by, then you may not even need to use those parentheses.
Also, something that happens with this calculator that I use is when I hit LN, it opens parentheses. What did we say you got to do if it opens parentheses? You've got to close them. So on this problem, when I start punching
I'll be punching in the extra, as you start punching it in there, I'll put in the extra parentheses.
I'm going to start.
Put it there, height on that.
Oh,
that's too busy.
Oh, okay.
Yeah, there. The 4. Just made that up.
It has the only thing that it has to do with this problem is
the need for the parentheses.
If you have more than one number on top in parentheses, on top of a fraction, you've got to put it in parentheses. Okay, that's what that was. A very poor. Okay, I'm going to be quiet.
Okay, I'll make a note not to do that
again. Okay. Yes. So I'll go to parentheses. That's the red parentheses. LN.
2 LN. Look, when he pressed that LN, it opened a parenthesis. So now I'm going to have to put a parenthesis around that 3. He types in, in front of the 3. He types in the 3. What does he have to do? Close the parentheses.
So blue parentheses.
The blue parentheses. And what else does he need?
The red
parentheses. You're going to have nested parentheses. If your calculator is like this TI,
when you hit LN, if it opens parentheses. I remember first time I ever saw them starting all these parentheses. The original TI-85, it never opened parentheses, and that was great.
Oh, it was.
But that was, they quit that 25 years ago. Yeah. Divided by, now I'm about to hit red parentheses. I'm going into the bottom. 6 LN 3.
It opened a parenthesis around that 3, so what does he need to do? Close the parentheses.
Then we have subtraction.
And if your calculator has a different negative sign from subtraction, you make sure you're using the minus sign. If you use the negative sign, then they're going to treat it as 6 ln 3 times a negative ln 6.
Ln 6.
Oh, wait. He typed that ln. It opened a parenthesis. He has to close the parenthesis after the 6. And then he still needs to close the parenthesis that's around the entire denominator.
Oh gosh.
How did it say to round?
Oh, look, this one says round to 3 decimal places. And if you punch in 4, it's going to count it wrong. Okay.
So that's a...
approximately.
That's a 0.45, 3 decimal places. Is that staying a 7 or is it going up to an 8? Going up to an 8.
0.458. 0.458. I probably should have put a 0 in front of it. Glancing at it, it looks like 458 to me. Now, this is especially a time when you might mess up entering and you get an error warning. Oh,
I don't think that happens. If it does happen, I think you're making a mistake.
Okay.
Number 3.
Oh, I can't overemphasize these little parentheses. If your calculator opens them, you've got to be very careful watching them. What about those wonderful Casios? Do they open parentheses when you hit ln? You do? Oh, okay. So
what about, do you have one of the little, just a fraction bar hot button, so you enter it like a fraction, but not using the divided by slash?
We have to use this. Do y'all have a...
Yeah. How did you enter it? Did you use the divided by, or do you have... Yes, okay.
Then you got to put that top in parentheses and the bottom in parentheses. Now
go back. The answer. Yes. Wait. Here it is, 0.458.
Yeah.
Okay. Once again, I really like the 3s and the 6s, I guess, because people make that mistake of rewriting 6 as 3 squared, but we can't do that. You have to take the natural log of both sides. When you can't get a common base, you stick an ln in front of both sides. Then
Tim.
There are hands. Okay.
Let's see.
Let's wait a moment while we take some questions. Y'all be thinking about what I'm going to write next on this. And while my brother's helping a student, I should point out, we do have a set of twins. I didn't know April had a twin sister, but I tell you, they could fool me. They could fool me. If April's sister came in wearing April's blue hoodie, I would believe it. They look so similar. They're sort of hidden behind that wall for those of you. I can't see them because of that support pillar there, but oh goodness. Experience shows if we pause the recording, it messes up. So I'll make a note for future reference. Well, don't put this into one of the MyLab courses, since we're just going to sit here and stare at a blank screen while y'all think about what I'm going to do here. Okay. Goodness. I feel like it's a low barometric pressure day, but last time I checked, it was over 30. I have problems when it falls under 30 inches of mercury, but no, it's fine. So, but does anyone else feel just a little lightheaded, like they're on an airplane and stuff? It's just, I don't care. I think that barometric pressure on my phone is wrong. Why do phones need to be reading barometric pressure anyway? So maybe I should look at, that's what I'll do. I'll look at weather.com. Great idea. Yeah, so, yeah. The wind is 20 miles an hour. Oh, it's falling. It's down to 30.07 inches of mercury. I think I liked it better when barometric pressure was measured in millibars. Y'all have heard of those? Millibars, no? Okay. Y'all ready? Y'all know what I'm going to do next on this problem? The funny thing is, I was thinking this is going to go pretty fast. It's just not. I feel like I'm in slow motion. So, what do y'all think I'm going to do next? Okay, so I'm going to bring down the exponent. I'll start by bringing down the x plus 1. And notice how I'm enclosing it in parentheses, because it's two terms. ln 6 is just a number. 2 point something, but it's a number. So a number, if you want to multiply x plus 1 by a number, you need to have it in parentheses so that you can distribute here 2x minus 2. We can bring that down. Once again, enclose it in parentheses because ln 3 is just a number. And then we get rid of those parentheses. We need to isolate x. In order to do that, we need to multiply x times ln 6 is just x ln 6 plus 1 times ln 6. I don't even need to show the 1, do I? It's just ln 6 equals here 2x times ln 3. Don't get creative. 2x times ln 3 is just 2x ln 3 minus 2 times ln 3 is just 2 ln 3. Okay, so we went through our little process. We've done up to the multiplication process. We bring down the exponents and multiply. Now we're ready to isolate x, but we have two x terms, so we got to get them on the same side. Why don't we move the terms in a way so as to minimize? I don't guess it's going to make much difference in terms of the number of negatives. I think I'll take this x here, move it to the left, and the ln 6 I'll move to the right. So we're going to have x ln 6, moving that 2x ln 3, that'll become a minus 2x ln 3 equals, over here we have a negative 2 ln 3. What else are we going to have? The minus ln 6. We get all the x terms on the same side. So we collected the x terms on the same side, and now we factor out that common factor of x. So we're taking the x We had an x ln 6. We factored out the x, leaving us with ln 6 minus, we had a 2x ln 3. We factored out the x. What did that leave us with? 2 ln 3, I agree. And over here I still have a negative 2 ln 3 minus ln 6. So we factor the x out, which means the next step is to divide. We divide by ln 6 minus 2 ln 3. ln 6 minus 2 ln 3 to give us x equals here's the stuff we're going to have to punch into our calculator. On top, that's a negative 2 ln 3 minus ln 6. And on the bottom, we have ln 6 minus 2 ln 3. So let's dig out our calculator and let's clean off all that stuff there. If you're trying to enter in a fraction with any operation other than number divided by number, to make sure that your calculator is doing what you want it to do, you need to assume parentheses on top, parentheses on bottom. You want to override your calculator's built-in order of operations. You want to tell it, simplify the top, simplify the bottom. The last thing you're going to simplify, the last operation is that division. So he typed the parentheses. Those are the red parentheses. And then negative 2.
If your calculator uses the reverse notation, you would hit the 2 and then a plus minus key to make it negative. But again, it's going in reverse.
So we have a negative 2 ln, and notice it opened a parenthesis, so we have to close it once he types in that 3, minus.
Oh wait, I think I hit the wrong thing.
Minus ln 6. It opened a parenthesis around the 6, so we have to close it. And then close another. He just closed that red parentheses right here. Divided by. So he's moved down to the denominator. The first thing he has to type, the red parenthesis, ln 6. It opened the parenthesis around the 6. We have to close it. Minus 2 ln. It opened, so close, close.
Okay, and hit enter. If you're just using a reverse notation, I'll write those steps out in a moment and give them to you.
Okay. How do they want it rounded?
Let's see, how do they want this rounded?
Oh, this time they say to the nearest thousandth. What is that? How many digits? 3. Tenths, hundredths, thousandths. So it's still just 3 decimal places. They're just saying something different. So let's switch back to my paper so I can write it. That's a 9.83. Is that going to stay an 8 or is it going to go up to a 9? Stays an 8.
Yep, the digit after that 8 is a 0, so definitely stays an 8. 9.83
3/8.
Okay.
Oh, one more, number 4.
Okay, wait. I want to write that down.
Oh. Oh. Okay. Number 4.
Let's see, next question.
I'm going to see if
This one you begin to see why.
I want to see. This is going to use something that we were doing at the very end of class the last time. I'm going to see which of y'all remember what we were doing. E to the negative 0.14t is equal to 0.69.
Okay. Now, let's see, type an integer, round to 4 decimal
Four
places.
decimal places.
So let's remember
Good.
that.
I'm glad you checked that. Okay. Remember I said if you're solving an exponential equation with an e on one side, if you can get the same base, you better have an e on the other side. Otherwise you can't get a common base. There's no e over here. So we stick the ln in front of both sides. And what's about to happen? Something's going to happen. Make this a very nice problem. That's right. They're inverse functions. That's that stuff we were doing there at the end of class the last time. Remember we said they were inverse functions. It didn't matter the order in which they were performed as long as the functions were performed consecutively. There, I think I stated it for log and ln. As long as the functions are performed consecutively in either order, they cancel themselves out. So look at this. The ln e cancels out. All we have is a negative 0.14t on the left. On the right, we have a ln 0.69. What do we need to do? We only have one t term, so we have to move terms around and factor out t's. There's only one thing left to do. Divide by negative 0.14. T equals ln 0.69 and a negative 0.14. So, how many times are you going to be pressing that ln button here? Just once, okay?
Hey, do I need parentheses?
What do y'all
around the
think?
top?
Does he need parentheses? Adding the parentheses is never wrong, okay? Not adding them, but using parentheses. It's never wrong to enclose the top in parentheses and the bottom in parentheses. But I think the only operation we see here is division. Number, it's a messy number, divided by number. So we don't really need the parentheses. I would highly recommend that you use them, though. So,
You want to put them around it?
yeah, I'm
Okay.
going to.
Here we go. ln 0.69 close parentheses.
Okay, it opened a parenthesis, so you got to close it, and then close
So
again.
gotta have two parentheses there.
Right, divided by a negative,
Parentheses.
a parenthesis, negative 0.14, close parentheses.
Do you remember how did it say to round?
4 decimal places. So that's approximately 2 point, is that a 650? Is it going to stay a 4 or go up to a 5? It's going to go up to a 5, I agree.
let me move this out of the way. 2.6505.
And now logarithmic equations. The name of this assignment was exponential and logarithmic equations. So now we're going to solve logarithmic equations. We've already solved some logarithmic equations in the previous assignment. Some of the first problems we did, we used the fact that, oh, switch over to my page. Okay. In the previous assignment, we used the fact that b to the log base b of x is equal to x, and if you reverse the order, log to the base b of b to the x reduces to x. And I recall a problem, I think it was the last equation we solved in that previous assignment, that introduced us to this concept of that we use for solving exponential logarithmic equations. This is where'd it go? There. Number 5. Okay. Log base 2 of the binomial 4x minus 9 is equal to 1. Log base 2 of 4x minus 9 equals 1. And notice they didn't tell us that we're going to have to round our answers. So we're not going to be getting decimal approximations here. What we're going to do, let me go back to what the last time, before we started. That's how we started, isn't it? Oh, let's see.
Go back, number 4. Here.
Oh, I didn't see number 4. Do I remember what we would do? Log base 5 of x equals 2. We said to cancel out a log base 5, we need to make it use an exponent base 5. But if we turn the left side into exponents to maintain equality, we've got to turn the right side. It's the same thing as that same base method for exponential equations. If the bases are equal, the powers have to be equal. Now we're going in reverse. The powers are equal, so the bases have to be equal. And with that in mind, I look here. This is very similar to that one that we did earlier, except the argument is more than just one term. It's not just an x, but that's okay. The base is a 2. The base on the logarithm is a 2, so we're going to use a 2 as the base for our exponent. 2 to the log base 2 cancels out, and that leaves us just the argument 4x minus 9. Now this looks funny, but it's saying 2 to the first power. 2 to the first power is 2. Now we don't have exponents, we don't have logarithms. This is a linear equation. There's only one sensible next step to solving a linear equation. And you know something? That looks like a 2 to the 2 to the 1. So I'm going to have to make a little, there, I'm going to separate it, okay? 2 to the first became a 2. What do I do next if I'm trying to get x by itself? To give us 4x is equal to 11. And then divide by 4 to give us x equals 11 over 4. Remember when we started logarithms, I said the base of the logarithm has to be a positive number. It can't be 1. but any other positive number. And we also said that a positive number to any power will always be what? If it's a positive number and you raise it to any power, what sort of a number are you going to get? Better question, what sort of a number are you not going to get?
Positive.
A positive raised to any power. Will you ever get a negative number? No. It will always have to be a positive number. So with that in mind, we started off solving an equation that contained logarithms, which means this thing here can't be negative. We ended up solving a linear equation where x could be anything. You need to make sure, once you get that x value, you have to make sure that the argument itself is still positive. If you plug in 11/4 there, 4 times 11 over 4 minus 9. If you plug in that 11/4 in place of that x, are you going to get a positive result? The exact value doesn't matter. You just need to make sure it's positive. The 4's cancel to give us an 11 minus 9, which is a positive 2. So yes, 11/4 is acceptable. Suppose we'd gone through all that and we got x equals 1. Would x equals 1 have been an acceptable answer? If you had gotten a 1 and you plugged in 1 there, is this thing positive? You would have a 4 minus 9, that's a negative 5. Suppose you'd gotten x equals 2, would that have been an acceptable answer? Because the 8 minus 9 is still negative. So don't just think to yourself, as long as x is positive, you're okay. No, you could have positive numbers that would still give you a negative argument. But this isn't nearly as bad as those square root equations where we had to manually plug in. All you have to do is make sure that that argument right there is positive for whatever x value you get.
And maybe the next problem would be a better example.
Probably.
I forgot, what is it, 11 over 4?
Yes.
Oh, I think that's close.
Okay, now I'm going to write a general process. Oh, no, I'm not writing the problem. Oh, I'm not writing the problem down. I'm ready to write down or summarize what we just did. I'll say, to solve a logarithmic equation, if necessary, let's see, I'll say, if necessary, condense logarithms so that the equation is in the form single logarithm equals a number. You want a single logarithm by itself. Remember when we were condensing those logarithms the last time? Hopefully you remember how we were doing that. The first problem we did, it was already in this form. Single logarithm equals a number. If you look at number 5, it was a single logarithm and the number 1. Single logarithm on one side, the number 1 on the other side. But when you look at number 6, notice there's 2 logarithms on the same side. We're going to have to condense those. So be thinking about that as I write out the rest of the steps. Once we got that single logarithm, we're going to use whatever the base of the logarithm is as an exponent to cancel out the log notation. Does that make sense? We'll use the base of the logarithm so that it's the base of an exponent to cancel out the log notation. Number 2, use the logarithm base. I think that sounds better. Use the logarithm base as an exponent base to cancel the log notation. That sounds complicated, but all I'm saying is, whatever that little subscript is, you write it big there and there, cancel the log notation. And then once we've done that, you have an equation that'll either be linear or quadratic, but either way, it doesn't have logarithms in it, and it's not exponential, so you'll solve the equation. And step number 4, you have to discard any solution that has a negative, that results in a negative argument. And you think of a clearer way to say that? Do y'all understand what I'm saying? Discard any solution
That gives you a negative number after the logarithm.
Okay, that gives you a negative number after the after the logarithm.
Or just a negative argument.
Okay, so in parentheses I'll put argument.
Argument is what you call that number after the logarithm.
Mm-hmm.
Not new terminology. We've been using it now for a week. Okay?
Okay.
We're going to try that strategy.
We're going to need to get the equations. Your general goal, single logarithm equals a number. Whatever the base of the logarithm is, use that as a exponent base to cancel the log notation. You then have an equation that you can solve by traditional methods. You then have to make sure that that number, when plugged into the argument, doesn't give you a denominator of 0.
No, a negative number.
Negative number. I'm sorry, we're not getting a denominator of 0.
Let's do number 6.
Number 6.
Just sort of play around with these.
What is that? A log base 6 of x plus log base 6 of x minus 5 is equal to 2. Okay. Hey, the equation's half right. We have equals a number. We need the equation in the form single logarithm equals a number. We have the equals a number right there. Well, we don't have the single logarithm on the left side. We're going to have to condense those logarithms. I'll write the log base 6. First question. Do I need a fraction bar? No, because the logarithms are not being subtracted. So you can't divide. You're not going to divide the arguments. What's the only other operation you can perform to these things? Multiply. X times x minus 5. And we now have the desired form. We have a single logarithm equals a number. I need to cancel out that log base 6. To cancel out that log base 6, what will I do?
What big number do you need now?
I'm going to write the number big twice. What number am I going to use? The base of the logarithm becomes the base of the exponent. We're up to this spot right here. Use the logarithm base as an exponent base to cancel the log notation. You just cancel that out. Well, x times x minus 5, we know we're going to have to do what there? So you have x squared minus 5x.
Don't say
What have we
12.
got on the right side? It looks funny, but it's trying to say 6 squared, which is
36. Problem 5.
So here on we're ready for step number 3. Solve the equation. You were going to say something about
Problem number 5, it was a linear equation. There was no exponents. Here, what do we have? What kind of equation has an x squared?
quadratic, which means we're going to need one side of this equation set equal to 0. What do you think I'll do? Minus the 36. So we have x squared minus 5x minus 36 is equal to 0.
Uh-oh, look at what's it just now froze all of a sudden.
Oh,
Well, should I hit stop?
well, it's still running forward.
I know, it's recording us sounding like idiots.
Yeah, but look at that, it's frozen. If this were a paranormal activity movie, they would be
It's a
stealing our
ghost.
spirit or something
Oh,
right now.
okay.
But no. Okay, don't do that. Let's just stop it.
Stop it.